Welcome to electrochemistry. In part 1 of this unit, we're going to be reminding ourselves how to find the oxidation numbers for elements in a compound and what redox reactions are. Everything from at least this first video is all a rehash of things we did in the reactions unit earlier in the year, but we're doing it again as it pertains to electrochemistry. So let's get started. Okay, so oxidation numbers. Essentially, this is going to be the charge of an element that's inside a compound. So to determine the oxidation number of elements in or out of compounds, remember the following guidelines. Atoms in their elemental forms, that's including diatomic molecules, are always zero. So for example, hydrogen's diatomic molecule has a charge of 0. Iron, which is just a single atom, has a charge of 0. Anything that's a single element, hydrogen, iron, oxygen, neon, has an oxidation number of 0. Hydrogen and alkali metals, or group 1, are always +1 when they're in a compound. That is, except when hydrogen is bonded to a metal, hydrogen has an oxidation number of -1, but this is really rare. So if you had NaCl, then the Na would be +1. If you had HCl, then the H would be +1. If you had NaH, the alkali metal is going to be your +1, but hydrogen will be -1. But that's a really, really rare circumstance. You're not going to come up with that very often. And then finally, oxygen is always -2. Except in peroxides, H2O2, where oxygen is -1, but again, this is rare. So if you have something like water, oxygen is -2. But in hydrogen peroxide, hydrogen is +1, oxygen is -1. If a molecule does not contain any of the above, or silver, zinc, aluminum, 1, 2, 3, or something else that's very common, the more electronegative element has an oxidation number that matches its group on the periodic table. Real fast, remember electronegativity. Here's my periodic table. Increases as you go to the top right. So the more electronegative element is close to fluorine or chlorine or oxygen. So let's determine the oxidation number for each individual element in the compounds below, starting with KNO3. K is an alkali metal, so that's a +1 charge. +1. Oh, let me make that prettier. K is a +1. And then oxygen is oxygen, so it's a -2, because that's what oxygen is. Now, there's 3 oxygens in this compound, so total, that's a total of -6. Also notice that this compound has no overall charge, so the overall charge is 0. So what should potassium be to fit in, or sorry, what should nitrogen be to fit in between potassium and oxygen? +1 plus what? -6 is 0. Hopefully, in your head, you're saying +1 plus 5 -6 is 0. So that's your nitrogen oxidation number. All right, so let's look at H3PO4. Again, there's no number written up here in this corner, which means the entire thing is equal to 0. Oxygen is -2, because it almost always is -2. But since there's 4 of them, we're going to call that -8. Hydrogen is +1. Because hydrogen is almost always +1, but since there's 3 of them, we're going to call that +3. So what can phosphorus be? What can fill in that blank? +3 plus what? -8 equals 0. Hopefully you got +5. Okay, so now we have CO3 -2. Notice that there is a -2 up here in the corner, which means instead of the whole thing equaling 0, the whole thing's going to equal -2. Coincidentally, oxygen is also -2, and there's 3 of them, so that's a total of -6. So what number -6 equals -2 rather than equaling 0? We got +4. All right, so now we have Al2S3, SO4 -2, and FeCl2. Pause the video now. Go ahead and try these 3 on your own. Okay, I hope you paused it. Okay, here we go. Al2S3. The entire thing is going to be equal to 0 because there's nothing written up here in the corner. Now, as far as aluminum and sulfur, we don't really have a charge for either of those 2 things, but I do know that aluminum is like 99% of the time a +3. So I'm going to put aluminum as a +3. Oh, sorry. But there's 2 of them, so that's a +6. And so what number +6 equals 0? Hopefully you're thinking in your head, minus 6. So plus 6 minus 6, but I know sulfur itself is not minus 6 because, again, there's 3 of them. So each individual sulfur is a minus 2. Now we have sulfate. That's going to be a total of negative 2. And oxygen is also negative 2. Times 4 is negative 8. So what number minus 8 equals negative 2? And you're getting negative 6. And then we have FeCl2. Neither one of these is on your always remember list, so chlorine is the one that's most electronegative. And chlorine has a charge of negative 1 compared to the periodic table. But I'm writing down negative 2 because there's 2 of them. The whole thing equals 0. So what number minus 2 equals 0? And we got plus 2. Okay, let's try just a couple more. We got Na2SO3, PbSO4, and MnO4 minus. Pause your video now. Try these 3 on your own. Okay, I paused my video. Did you pause yours? Okay, Na2SO3. Since there's nothing written up in the corner, nothing up there, the whole thing equals 0. And then oxygen, I'm going to erase that and write down oxygen is negative 2 because I just know that automatically. Times 3 is negative 6. Sodium is plus 1 because it's an alkali metal. Times 2 is plus 2. What number? Plus 2 minus 6 equals 0. And we have a plus 4. For the next one, again, it equals 0 because there's nothing that's written in the corner. Oxygen is negative 2, and there's 4 of them, so that's a total of negative 8. And then I get stuck because now I have a PB and an S, and, well, neither one of them are on my things to remember. So here's what I'm going to do. I'm going to say that I remember that sulfate overall has a negative 2 charge. And there is 1 sulfate in this compound, and there is 1 lead in this compound. And if sulfate has a negative 2 charge, then lead must have to have a positive 2 charge. And if lead has a positive 2 charge, then the individual sulfur has got to be a positive 6. All right, last one. We have MnO4 minus. It's MnO4 minus, so the whole thing equals minus 1. Oxygen's negative 2, and there's 4 of them. What number minus 8 equals negative 1? We got a plus 7 for the manganese. And that's how you're going to determine oxidation numbers in a compound. Next thing we're looking at is what is redox. So remember, redox is reduction, oxidation. So the term oxidation means the loss of electrons, or the oxidation number increases. Oxidation is loss of electrons. Oxidation is loss of electrons. Gain in charge. Oxidation is loss of electrons, gain in charge. Oxidation is loss of electrons, gain in charge. Oxidation is loss of electrons, gain in charge. Say it with me. Say it with me out loud. Oxidation is loss of electrons, gain in charge. Did you say it? Okay, what about reduction? Reduction means gain of electrons, or the oxidation number decreases. Reduction is gain of electrons, loss in charge. Reduction is gain of electrons, loss in charge. Reduction is gain of electrons, loss in charge. Say it with me. Reduction is gain of electrons, loss in charge. If you have oxidation, you must have reduction, because if one of them's gaining electrons, they have to be coming from somewhere, and if somebody's losing electrons, they have to be going somewhere. So where are the electrons here? We're going to determine whether the following processes are oxidation or are they reduction, and then we're going to complete and balance the half reaction. So notice I have copper turning into copper plus 2. The copper on the left is elemental copper. That's plain the element. So the copper on the left has an oxidation number of 0. So oxidation is loss of electrons, gain in charge. So here I'm going from 0 to plus 2. That is a gain in charge. So this is Oxidation. All right. So now, where are the electrons? If we're going from copper to copper plus 2, that equation is not balanced because there's 2 electrons missing. And I'm going to put those 2 electrons on the left-hand side. That way, on the right, I have 0, and on the left, I have 2 pluses and 2 minuses, which cancels out to 0. All right, now we have Cl2 to Cl minus. Cl2 is elemental chlorine, so that's 0. 0 is going to negative. Reduction is gain of electrons, loss in charge from 0 to negative. So this is reduction. All right, reduction is gain of electrons, loss in charge. Now all I've got to do is balance the equation. I see that there's 2 chlorines on the left, so I need 2 chlorines on the right. But now my right charge is a -2 and my left is a 0. If I were to put the electrons on the right-hand side, then I'd have a -4 on the right, which is not going to work. So I'm going to move my electrons to the left. And 2 electrons because that's how many I need to balance my charge. So now I've got 2 negatives on the left, 2 negatives on the right. We have a balanced equation. I wanted to do that in, let's do red. Okay, last one is Cr plus 3 to Cr. The Cr on the right-hand side is elemental chromium at 0, so we're going from plus 3 to 0. So from plus 3 to 0, that's going down. That is reduction. Reduction is gain of electrons, loss in charge. All right, so now all we need to do is figure out where the electrons are. I need to get both sides to be equal to each other. They don't both have to equal 0, they just have to equal each other. Currently I have 0 on the right and plus 3 on the left, so I'll need my plus 3 electrons on the left to give me 0 on the left, 0 on the right. Notice that for everything here that I called reduction, both of these guys are reduction, and both of the electrons are on the left-hand side, because reduction is gain of electrons. And so these things, these reactants, are gaining these electrons to turn into the products. Whereas the one called oxidation, since it's losing electrons, the electrons are a product. So reduction will always have electrons as a reactant. Oxidation will always have electrons as a product. And that's all for now. Remember, this is just a rehash of the redox that we did in our reactions unit, but hopefully it cleared a few things up. We'll see you next time.